Hello everyone, today we are going to go through grade 12 math paper 2. Math paper 2 is usually the question paper that most math students hate, and it usually goes really bad. Like your paper 2 is always bad, and that's what we're going to look at today.
Mr. Viljoen, I see that your camera has just suddenly switched off. Right, how are you doing?
I'm doing fine, and you?
I'm good, thanks. Okay, so paper 2, when we last spoke, you've said that this is something that especially your matrics always struggle with.
Yes.
So I know that we tend to say to the kids practice on past papers often, but I've got a couple of questions that I do feel is very important. So, for example, my first question here is, where are the learners losing the most marks in the paper? So I don't know if you perhaps have something that you can just share with us.
I do have something that I can share with you. Okay, so this is the standard math paper 2. This is a DBE paper from last year. This is a prelim paper from September. So, questions where kids lose marks. Okay, first of all, if you have an example or a question where you've got analytical geometry and Euclidean geometry involved, there's definitely going to be a few learners losing marks at a question like this. Okay.
Why?
First of all, because what is found most of the time is that some of your grade 12 learners have forgotten your grade 10 and grade 11 basics when it comes to this. The circle concept is learned during the grade 12 year, and not all of the students are quite comfortable with the circle topic. There's not in the grade 12 curriculum. Essentially, you have around 6 months to complete a year's worth of work with the grade 12s. Okay, so the time and amount of time that you have on this topic, for instance, the new topics for the year, like for instance, with the analytical geometry, you add in circles. You don't have a lot of time on that. It's usually just a class, it's 2 or 3 classes about it, and then you go on to the next topic because you have to try and finish your curriculum by end of July at least, because when the kids come back from term 2 vacation, they've got a bit of term 3, then they've got prelim. So in that time, it's actually recommended that you revise prelim papers with the kids. But now, when it comes to past papers are not the best way to revise, because every past paper is different. One past paper can have this question, one past paper can have that question. Most of the time, they copy and paste past papers onto each other, like one question from that past paper and that past paper. So initially, when it comes down to this, it's a bit, you can prepare do as many of these question papers. It will teach you how to do the basics and how to adapt, but it's not going to be able to teach you or learn you how to adapt to the current paper, because the current paper might use a different format. I think we saw that last year with Sakai's papers. Okay, the general format was just overwritten and the new format was given. Okay, so
Okay.
that's the.
Sorry.
Okay, so now another place where kids lose marks is trigonometry, because kids don't understand how to do it. They don't. Okay, they can know their basic rules, but when they get to the test or exam setting, it's like some of them freeze up. For instance, I found that my matrics last year, trigonometry was the place where they actually made marks instead of where they lost marks. Usually trigonometry is where kids lose marks, because they struggle with especially the new stuff, the double angles. They struggle with that, and that really comes out. Then trig functions is fine. 3D trig is also a thing, because kids don't remember, or they kind of sort of, when they get to question 7, they've got a little time left, like let's say 30 to 40 minutes, and then it's like, oh, well, now I have to do this. And then the whole rule book goes out the window essentially with this question, because now they forget that they have to apply the sine rule for the different angles and to find it. Okay, so this is the part of 3D trig. So 3D trig is also a topic that needs to be focused on quite a lot so that kids get used to it. Because now, remember, they are new to 3D trig. They're not new to the sine and cos rule, but now we're applying it in three-dimensional trig. So it's a different concept from where they were on the grade 11 stage. Then the last part where they lose a lot of marks, and this happens every time, is Euclidean geometry, especially circle geometry. Okay, most of the time, the circle geometry is there to catch you off guard. Okay, and most of the time when students get to this part, well, let's say your 3 hours have almost been nearly spent, and then this is usually where students start rushing through it. For instance, if you look at question 8.1, the thing that you need to do here first is draw a construction line. So if I had to draw a construction line for this question, because that's your first part, because you have to prove that this is a cyclic quadrilateral. So your first part is you're going to basically draw a construction line from that point to that point, like that.
Okay, if I can interrupt you, sorry, because I'm already a little bit lost, right? So circle, just go back to that circle geometry question for me for a second, okay? Now, we've got a thing that's worth a lot of marks, okay? What is the step-by-step approach specifically with this that the kids should be taking? So if you could say step 1, do this, step 2, do this, step 3, do this. What is that? And then also, what is the biggest mistake that learners make when working with tangents and obviously radius?
So the first step that they have to take with a question like this, we have to prove, for instance, it's a cyclic quad, is they have to make a construction. Okay. Then they have to use their general theory. Okay. They have to know their circle theorems around the cyclic quadrilateral to be able to do this. So for instance, idea is you have to prove that if you take angle P and R, if added, that they give you 180. So there's multiple ways of approaching this. So, but the first step is your construction, and then comes in the next part. So a cyclic quadrilateral is based on the fact that it has 4 sides. Okay, that can obviously be seen here. And now this theory is eluding me as well. Okay. Okay. But most in general, kids need to focus on the general theorems to prove that this is a cyclic quad, because now it would be, for instance, so if we take from our construction, that this would now basically, most of the time it's going to use your basic rules and principles. So if you've got it like this, it can be a different construction as well. Doesn't have to be this type of construction, but you can basically essentially, my brain doesn't want a brain today.
Okay. What is a construction? Is that the line that's going right through there?
Yes, that's a construction.
Okay. So would you say then that step 1 is they have to first draw that line, figure it out, and then obviously they should know that P and R together would equal 180 degrees, but at the same time S and Q would also equal 180 degrees.
Exactly.
Okay. So when you were talking about the theorem, is that essentially what you mean by saying that?
Yes, that is the theorem. You need to go and prove the theorem now.
Okay.
So now there's a few ways of proving a theorem when it comes to circle geometry. Either you use congruency with your triangles. Okay, triangle theorem falls a lot into this, but now the reasoning that you're going to use is a lot different from normal Euclidean geometry.
Would I be correct as to say when we talk about triangles, that's the mathematics that learners would have learned in grade 9?
Yes.
Okay.
Okay, for instance, if we look at question 8.2, so this is where it comes into play. So first of all, we need to be able to identify, okay, PR is a tangent, okay? Tangent is usually 90 degrees. Then your different theorems, for instance, determine the size of V. So first of all, if you look inside, we actually need to see that this is a cyclic quadrilateral. There. You guys see that?
Yes, quadrilateral meaning a shape with 4 sides.
Yes. So now because this is a cyclic quadrilateral, so I would be remiss to say, for instance, V is equal to 180 minus 67, and that would be cyclic quad. Okay, that's the abbreviation for it. So then that would give you angle V. Because in essence, the theory around a cyclic quad is that if you add the opposite angles of a cyclic quad, they give you 180 degrees. Okay, that's a solution to it. Then, for instance, determine the size of S1. First and foremost, note that you have a tangent, that you have a line that is extended like this. Now, this is an outside, this would be considered like an outside angle. So, for instance, now, this is where kids also get confused because most kids would go straight and try to use normal Euclidean geometry to do this. For instance, normal Euclidean geometry says, well, okay, since this line is a tangent, okay, so that W would be equal to 180 minus 108, okay, because that would be the general theory angles on a straight line. It can be used, saying it's incorrect, but it's not recommended to use it.
Okay, and why don't we recommend using it? What should they then rather be using instead of Euclidean, or you said Euclidean geometry?
And they should be using their circle theorem. They should be using their circle theorem reasons for this. Okay.
And can you give us a very brief description? What is the circle theorem?
Okay, circle theorem is like for a cyclic quad. Opposite angles on cyclic quadrilaterals equal to 180. Tangent is always perpendicular to the circle. Okay, it's always 90 degrees. For instance,
perfect. So now that we've also gone in a circle talking about circle geometry, would you say that that is like obviously where the kids are losing the most marks? Because I mean, you're sure this question is only 11 marks, but if you add them all together, is the paper mostly circle geometry, or is there other stuff that we have to consider as well?
Most of the time kids, and then, okay, proportionality is not so bad. Okay, kids usually get proportionality. But now, for instance, when you have a question that is combined, so this uses proportionality and your circle theorem together. But
okay, can you define proportionality for me?
So proportionality, where's a place where I can just draw a basic little sketch? So proportionality is saying, let's say I've got two triangles in this format. Let's say this is A, B, C. Let's say this line is parallel to this line. So this would mean, let's call this DE. So this would mean that AE is proportionate AE over AB is proportionate to AD over DC. Okay, they're in proportion to one another. That's the general theorem around proportionality. Okay, that's not that hard a concept.
Okay, that makes a lot of sense.
But sometimes we can add trig into it as well. Okay. So most of the time, what gets the kids is not essentially the questions, but it's the combination of types of questions, for instance, and the combination of what is in the question. So it can be an integrated question. I know Sakai likes the integrated questions. So with the integrated questions, it is very important to realize that now you're doing math now you're doing more of an applied math. Okay, because now you're applying different disciplines in math to do one question, for instance, trigonometry and proportionality, Euclidean geometry and circle geometry.
How would a child define, or I say child, but these are teenagers, okay? How are they going to be able to identify when it is a integrated question like what you were just describing?
So for instance, if you look at this question here, this question is definitely integrated because now you've got your triangle there. So now, first question that they ask you is prove that triangle CEV is congruent to triangle CAE? That's your first question that they ask you. Or, well, they say BCD is a cyclic quadrilateral and you have to prove that. So now identify BCDE. There it is. So now we have to prove that this thing here is a cyclic quad. So
Would you say that a child needs to take a lot of colored pens in with them when they're going to do maths?
When they do circle geometry, I would recommend it. It makes it easier because then you can identify, okay, I'm working with this. Okay, because you don't want to sit there halfway through. You've already written so much, and then it's like your brain is like having a moment. It's like, oh, it's gone. Okay, because that happens. That happens in math. And I've seen it in so many assessments that I've marked with mathematics, especially paper 1 and paper 2, especially paper 2. Like the kids have it for a second, and then suddenly you see, oh, well, they don't have it anymore. They had it, but then it's gone. So it's to keep your focus with this, because now you're going into this and saying, well, okay, so first thing that I'm going to say for instance, here to prove that this is a cyclic quadrilateral, the first thing that I would say is that, okay, if I look at angle D, that is equal to E4 because it's opposite sides.
Okay.
So angle D, right, is equal. So this would be angle D is equal to essentially. And also another thing that proves it's a cyclic quadrilateral is ons grap altyd en sê dis 'n struktassie. Nee, as jy mooi kyk, maak hy 'n lekker struktassie hierso. Daar's 'n struktassie. Okay. So what I know around this theorem is that B3 is equal to E4, because it would be, so we can say E4 is equal to B3 because it's angles in same segment. Okay, C2 is equal to D1, angles in same segment. And that also proves, oh, therefore BEDC is a cyclic quadrilateral, because that's one of the theorems. There's different theorems around the cyclic quadrilateral. For instance, if we go back to, for instance, this one here, ne? Okay, so bear with me. So you're going to say, well, okay, angle R, so this is O1, O2. So angle R is equal to, let's call it R1 and P2. So R1 is equal to angle O2. And this is angles in center of, angle at center. Angle at center is equal to 2 times angle at circumference. Okay, so this relates to your midpoint theorem for a circle. 2 times angle at circumference. Okay, so then you're also going to say, well, okay, P2 is equal, so P2, for instance, would be equal to O1, and that's the same theorem. 2 is equal to O1. Now, okay, now we get to a very basic theory. Now, angles around the point is how many degrees?
360.
Okay, so then we can say that O1 plus O2 is equal to 360. So that means therefore 2 times P plus 2 times R is equal to 360. Then if you divide by 2, you get P plus R is equal to 180. Then you can say, therefore, this is a cyclic quadrilateral.
Where did we get the divide from?
Because you have to divide this by 2.
Okay, I get you. I got you. Okay, got it. I'm there. Okay. So would you say that obviously when the learners are studying for this, what they should be focusing on is actually the application of the formula as opposed to just trying to remember the rules? If they can apply the formula, then they should automatically, it becomes muscle memory. The more that they practice the formula and those rules or that method, the easier it will be for them to answer the questions.
That's generally the consensus, like practice it till it becomes muscle memory. But what they need to do here is like the standard rule for any Euclidean or any geometry is practice it and apply the rule. Practice, apply rule. Practice, apply rule. So here we basically, first of all, we applied theory that, oh, okay, so first you draw your construction, then it's R1 is equal to O2 because it would be angle at center is equal to 2 times angle at circumference. That's the rule.
Okay, so they would then first do theory, then they would remember method, or they would remember formula and then method.
Yes.
Okay, perfect. Can we circle back quickly just to question 1 and 2 for me?
Yes, we can. Okay, question 1 and 2, stats. Okay, now.
Stats, fun. Okay, so over here, when we are talking about stats, there's a few things, or there's some vocabulary that I would like you to clarify for me. Okay.
Okay.
The first one is statistical reasoning.
Okay. So statistical reasoning within the world of stats means to understand statistics and to understand your definitive counting principles involved. So statistical reasoning would involve your mode, median, your basic stuff that you learned like in grade 4, grade 5, and grade 6, like your basic stuff of this. So
Okay.
that's where your statistical reasoning starts.
Okay.
Then it evolves. Grade 10, grade 11, grade 12. Then it evolves. Because grade 8 and 9, you deal with mean and median. Okay. Grade 10, we start dealing with the interquartile range and the out and up. So with your upper quartile and lower quartile. Okay. That's part of it. So then you need to know, okay, my lower quartile is half of my median on the lower end. And then you need to know my upper quartile is, for instance, half of my quartile on the upper end, half of my median on the upper end.
Okay. So when we talk about that, okay, statistical reasoning, we understand is now like being able to explain why something or the stats are saying what it is saying, right? My next question, though, is another word that I would like you to explain to us is predictions and regression. Because something that I do know that the kids struggle with is interpretation, but also what should learners check before making predictions from regression. So for us to understand what I'm asking, we just need to define regression.
Okay. So regression has to do with, okay, so, right, this relates back to functions. Okay, the regression is going to relate back to function. This, what we're seeing here, is actually a function. Okay. Functions, because you've got an x value, so your x and y value. So when we look at a regression, we're actually looking at like a decreasing pattern happening. Okay, so regression would be decreasing. So therefore, learners would be able to predict from the data given that there's either upward or let's say there's a negative or a positive trend to the data. Okay. So therefore, learners would either say, okay, it's skewed to the right or skewed to the left. Okay. Left being positive, right being positive on a Cartesian plane. So essentially, this relates and goes back into functions because now this is a real life applied function because now we're measuring the degrees towards the temperature. Each pattern here uses its own rule. So when it comes to regression, we need to be able to identify the rule first. Okay. Then we need to identify whether or not what is my least squares of regression. Now, another thing with stats, okay, which I hate about stats is, okay, you can do the formulas manually. You don't need a calculator to do it. If you know your formula, sub the values in. Right. But now, compare the answers that you get manually to the answers you get in a calculator. Completely different.
Why?
So, it's in the way that the calculator does it. Because basically, with the calculator, you have to type in and save your whole data set. Then you have to switch your calculator to stat modes, and then you can work out the mean, median, interquartile, outer quartile range. You can work out everything. You don't even need to do this with manually. So usually learners just take this as a calculator question because that's essentially what it is.
Okay. Would you recommend, though, that they do the calculator, or would you recommend that they do it manually?
If you want to get free 19 marks, I mean, use a calculator.
Okay.
This is your Mahala mark section. Okay, this is Mahala marks. Okay.
Okay.
Then Analytical geometry, Mahala marks as well, if you understand your theory around analytical geometry. Okay, this is something that kids are going to have to go and practice once again.
Okay.
Like this would tie into the grade 10, 11 work. Remember, grade 12 is like a summary of grade 10, 11, and 12.
Okay, so you would definitely then say your high mark sections are definitely anything to do with circle geometry, trigonometry. And then your Mahala marks, I mean, it's like any paper, right? You get your easy questions first and then you work your way to the back. I just saw a 23 mark question there. Can you just scroll up for me?
That's analytical geometry.
That's the analytical one. Okay.
Yes.
Analytical stuff would have been focused on in which grade?
We start in grade 10, term 3 with it.
Okay.
Right? Then we continue in grade 11. Then we continue in grade 12 with it.
Do you have any advice in terms of specifically analytical geometry that the learners would be able to carry with them as they are going to move into writing examinations now?
Advice, okay, know your formulas, know your gradient formula, know your distance formula, know your theory around perpendicular lines, know your theory around, let's say, for instance, a tangent and how to work out a tangent.
Okay, well, there we go. We've got some nice actionable advice there. And we've actually had a look at where we could have high intervention, if there is anything. So from your experience, you would say the kids really struggle the most with
Trigonometry.
with trigonometry. Okay. Let's look at that
Circles.
26 mark question. That's the tangent and the cosine and the the sine and all of that stuff. Do you have any specific actionable advice that learners can have for this?
Trigonometry, know your identities. Know your double angle identities. Know how to simplify it. Know how to apply reduction, cast diagram. There's a lot of things that you can apply for trig. For instance, if I look at, so for instance, if I look at 5.1, okay, that's generally easy, but now we have 5.2. You have to prove that this is equal to that. So this is, so if you look at 3 cos 2x, now you should notice, oh, that's a double angle. By the way, so cos 2x has 4 different identities. It's either cos squared x minus sine squared, or it's either 1 minus sine squared x. Or
Okay.
so
That looks very, very a lot.
Know your identities. Know when to apply what identity.
Would you say that it is a lot, or is it just something that comes with practice?
Honestly, I think it's something that's a lot, because even with practice, for instance, even if I have to go and do 5.2, okay, I'm definitely going to test all of my double angles first before actually settling on the correct one to get to that theory. Because now, for instance, there's also another thing that you can look at there. Oh, what can I factorize? See, there's another pathway. Meaning, oh, what do all of them have in common above? Oh, they've got 3 in common, so you can factorize out 3. So that leaves you with cos 2x plus cos squared x plus 3 sine squared x.
And factorization is a skill that they would have learned in grade 8, if I'm correct?
Yes, that is correct.
Okay. Awesome. Right. And I have one last question for you. And it's a bit of a hard one. Okay. If the learner has 2 weeks before their final examination, what should they prioritize in paper 2 to improve their marks in this specific paper?
Honestly, that's a difficult one to answer, because every learner struggles with different things. For instance, I had a learner last year that struggled with circle geometry was fine, analytical geometry was fine. Trig was the problem. Okay, and I went with this learner over trig so much, but the learner didn't retain it. So I told the learner, like, for instance, focus on trigonometry. We're going to focus on trigonometry for these classes before paper 2, because that's your problem area.
Okay.
So I would tell learners maybe just focus on the problem area. Okay, Also, practice the good areas that you're good in. Make sure they stay into practice. But majority of your time is going to go into the area that you struggle with.
Okay. And would you say then that learners should then rather begin on the things that they are good at so that they've got more time at the end to do the hard
Definitely.
stuff?
Okay, so there's a way to approach this paper. So you get 10-minute reading time. 10 minutes reading time before you start an assessment. That 10-minute reading time is you basically going to take your paper, you're going to open it, say, okay, question 1, question 2, okay, going to do that first. Then, oh, question 3 is easy, question 4 I can do, okay, question 5, difficult, question 6, okay, this I can do, I know how to do this, question 7, I can or not do this, I'm unsure about this, and then question 8 is like the general place where kids like, well, I have no idea what I'm doing. So just go and look through the paper in the 10 minutes that you have reading time. Mentally mark the ones. When they tell you you can start writing, go and take your pencil and mark the paper. Mark it. Okay, that you do question 1, question 2, that you do all the easy questions first. Okay, you can do it in any order as long as the questions are there. Okay, don't worry about the marker. They will sort it at the end of the day. That's their problem. They get paid for it.
Okay, then that is all the time that we have today. Thank you so much, sir, for your time and for guiding us through this paper. It was very informative, and I hope that it will help someone. If the learners do have questions, I do believe they should be able to pop it into the comments, and then you or I will get back to you and be like, oh, this child had this question. Would you be willing to answer some questions for us?
Definitely.
Excellent. Thank you so much. And then you should have a wonderful day.
Thanks, you too.